called inverse variation. So please wake up from your sleepy doldrums and try to follow along. I will do this as best I can. Now, in order probably to understand inverse variation, we probably should turn our Wayback Machines way back to when we talked about what's called direct variation. And the book shoots this at you. There are what they call the different equations for direct variation and inverse variation. I'm going to give them to you and then we're going to talk about them. Direct variation is an equation that's in this form. Y equals K times X. Indirect variation is in the form of Y. There's two different forms you can think of. Y equals K divided by X, or XY equals K. These are the same thing, just changed, right? If I had to get rid of this X, I'd multiply both sides by X and I'd get XY equals K. This is indirect variation. This is direct variation. I'm sorry, those are both indirect. This is direct variation. And here's an important part of all this. I'll try to explain it all later. Let's just put this simple stuff down. K equals the constant of variation. Anybody want to speculate what any of this means? Somebody. Please. Do you remember we talked about direct variation? Direct variation, children. Okay, first of all, if you look at this, this really is very similar kind of to a linear equation. Okay, if I were to graph this, no, I guess I can't because I made that. Let's just talk about direct variation is really the one that makes sense because when things vary directly, that means as one goes up, so does the other. For example, an example of direct variation would be a simple thing. If you get a job working for, what's the going rate per hour for a 14-year-old? Let's say you make $7 an hour. Your job is $7 an hour. Okay? That would mean if I made a table of my direct variation, X and Y, the constant of variation is 7. If I work 0 hours, I get paid 7 times 0 is $0. If I work 1 hour, I get paid $7. If I work 3 hours, I get paid, jump in here anybody, $21. As I work 5 hours, I get paid $35. Okay? Which makes sense. The more you work, the more you make. As one goes up, the other one goes up. Okay? Inverse variation is kind of the opposite of that in the sense of as one goes up, comma, the other goes down. Okay? One way to think about that might be like this. The amount of time that you spend goofing around, the more you goof around, the worse your grade. Inverse variation. Direct variation would be the more you study, the better your grade. Study more, grades go up. Inverse variation, goof around more, grades go up, down. Up, down. Another way to look at it might be the number of people you have working to get a job done. People and the time it takes to do a job. Okay? You know, if, let's say you're building something. X and Y. Let's make X and Y. I'll fill in the table and then we'll write the equation. If one person can do the job in 10 hours, well, no, let's make that 12 hours. One person can do the job in 12 hours. Two people can do the job in 6 hours. 3 people could do the job in 4 hours. 6 people can do the job in 2 hours. 12 people could do the job in an hour. Inverse variation. The more people you have, the shorter amount of time it takes to do the job. Now, if I'm writing that out in this equation, what is my constant of variation? If I take x and multiply it by y, what is 1 times 12? What's 2 times 6? What's 3 times 4? What's that? They all equal what? 12. 12. 12. 12. 12. My equation you can either write as x times y equals 12 or y equals k divided by, y equals 12. Y equals 12 divided by x. What if you had 8 people doing the job? How would you figure that out? Well, x is the number of people doing the job. You do 12 divided by 8. Doesn't work out evenly, but it is 1.5. 1.5 hours. Okay, inverse variation. You know something is inverse variation if every time you multiply the x and the y together, you get the same number. Okay, that doesn't work with direct variation. Okay, if I multiply 1 times 7, I certainly don't get the same things if I multiply 3 times 21. Now, for those of you here, wait, stop. Maybe this will help. I see somebody starting to doze. Oh. Okay. Now, take a look at what happens here. Here's something for you to think about. Look up here. Think about this. I didn't put this here, but what happens if I have 0 people working? How long is it going to take me to do the job? No, that means the job's already done. If you say it takes 0 amount of time to get the job done,
Infinity.
okay, you're kind of that. This actually cannot be done. You cannot have a 0 for either one of these. X and y really cannot both be 0. Why? Because if this is my equation, if I put 0 in for x, 0 times what number is 12? You can't do it. Or if I put 0 in for y, 0 times what number is 12? You can't do it. Here's what you have to see. If you look at the graph of these, let me graph this one. Let me change colors besides that putrid pink. Let's go with that ugly green. If I graph this one, look what it looks like. 0, 0 looks like this. 1, 7 looks like this. 321 is way up here. If I graph this, it looks like a nice straight line that does this. If I graph this one, do I have some room over here to graph this? I do. The graph of this looks like this. Okay, this is a direct variation graph. Looks like being proportional, yes? Directly proportional, below, whatever. This one here, if you get 1, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dot here. 2, 6. 2, 1, 2, 3, 4, 5, 6. Dot here. 3, 4. 4, 3. 6, 2. This is what an inverse variation graph looks like. It is a little curve that looks like this that approaches both the x and the y axis but will never touch it. Okay? Why is that? Because of this. If I said, here's my x, here's my y. If I said I had 36 people working on this job, 36 times what number gives me 12? 1/3. So if I'm graphing that, okay, I have 36 way over here, and I have to go up 1/3 of whatever. It gets close to that thing there. If I had 1,000,000 people doing this job, how long is it going to take me? It's going to take me 1,000,000 divided by 12, right? Which is some really tiny number. I will never get to this 0 point here. You can never, the biggest number you could possibly think of still will take you a little bit of time to do that job. You'll never get to this axis. Same thing with this, you'll never get to the y-axis. Because no matter what, it's always going to take you, what is this? How long it takes the job? It's always going to take you a little bit of time to do that job. So it'll approach that axis but never reach it, and it's always that loop. And as long as we're there, it also goes the same. There's also a reflection over here. If I put negative numbers in there, if I had -1 person doing the job, how long would it take? -12 hours. Well, for jobs, doing work would be that, but for other things it's true. You get an exact mirror image of this loopy thing down here. This mirrors this and that, first quadrant, third quadrant, because you can multiply two numbers together. The two negative numbers will give you a positive 12. So you can't have that. So you're asking, let's look and see what they have here. Let me see what the paper is. You guys really should wake up. This is the turning point in your mathematical career. Ready to call it on? Take a look at this. Other things that are inverse variation. The faster you go, the worse your gas mileage is. Wait, is there two different? Oh, sure. Wait. I guess you have to give me two of these. First and second page. First page, second page. First page, second page. Apparently I forgot to tell the printer to print out both sides. Oh, look at Sandy is utilizing our art during math. I got nothing against that. Sometimes it helps you focus a little more. I doubt it. Okay, take a look at this. Everybody's got one?
Yeah.
You have to what? You have to what?
Eyes.
Fingers. Wait, do you know that song? I got two eyes. You sung that song, Christian?
I do not.
Anybody know that one?
Probably Jake. I think Jake's.
This, by the way, is my favorite thing I learned about computers. This little snippet tool.
Yeah, it's the same.
Take a look at this. Look at the practice problems here. See if you follow along with me here. Is this, describe each equation, letter A, is it inverse or direct variation? Now you want to, before you say anything, you want to go back to your notes and go look at what we said the equation. Inverse and direct variation. Direct variation is y equals k times x. Inverse variation is xy equals k, or y equals k divided by x. This equation, can you change either of these to look like that? K equals y divided by x. Now here k equals this. Does k, can I get this one to look like this? K equal y divided by x. Yes or no?
Yeah.
Sure. If I divide out the x and divide out the x, look what I have. K equals y divided by x. This is direct variation. Letter B. Y times x times y equals k. Direct variation or inverse variation? Inverse, because it is this one right here. C. I told you the graphs of these. If it looks like it's proportional, it's direct variation. If it's a curvy thing that approaches the axis but never crosses them, it's inverse variation. Letter E. Look at this table. Are they inversely proportional or directly proportional? How do you know? Remember what I said? If you can take both the x and the y value and multiply them together and get the same constant, it's inverse proportional. What's 1 times 6?
6.
2 times 3?
6.
3 times 2?
6.
This is inversely proportional. Look at this one. 1 times 3,
3.
2 times 2,
4.
3 times 1.
3.
Not because they don't equal, they don't have the same constant of proportionality or inverse constant, directly unproportional, whatever. Letter F, if it takes 3 people working at an equal rate 5 hours to complete a job, how long would it take 5 people to complete the same job? So the question you ask yourself is that direct or inverse variation? The more people you have, the less amount of time it is. So that automatically makes you think of this. X times y has to equal k. I know my x and I know my y. 3 times 5 is, k has to equal 15. So everything else multiplied together has to give you 15. How long would it take 5 people to do it? 5 times what would give you 15? Yeah, this would have to be 3 hours. Because they have to, the two numbers always have to give you that same constant. Letter G, the volume of air in a balloon and air pressure in the balloon are inversely proportional. So right away, what should you write out? Volume and air pressure. Volume times air pressure have to give you some constant, because that's inverse proportionality. This is your x and your y. If the balloon is squeezed to 1/2 its original volume, 1/2 its original volume, by what factor does the air pressure increase? What number here would have to balance this off here to give you the same constant? 1/2 times what would give you the same thing? Maybe you'd have to double it, because they have to come up to give you that one thing. You could, by the way, if you didn't know that, you could pick any number you want to do that. Let's say the volume was 10 and the air pressure was 10. The constant would have to be what? 10 times 10 is, well, it said the volume was cut in half, which would be 5. 5 times what number would have to give you 100? So what did you do to 10 to get to 20? You doubled it, times 2. You don't care.